What is 12 miles long and protects the city of Paducah? The Floodwall, of course. I'm Pam Spencer, Public Information Officer. Coming up on this episode of Your City at Work, we'll find out what it takes to install the floodgates, and we'll learn about the history and the future of this incredible wall. The flood wall in downtown Paducah is 12 miles long total. You see the 3 miles of concrete, but there's also 9 miles of earthen levee. Behind me, what's going on is some training in installing the floodgates. But before we start talking about the training, let's go back in time, go back and talk about the history. So joining me now is our City Engineer and Public Works Director, Rick Murphy. Hey, Rick.
Glad to be here.
Good to see you. Before we talk about all this training going on, let's go back to the beginning of time of this flood wall. How old is this flood wall?
The flood wall originated, or the construction originated in 1939.
Okay.
And it took 10 years to build it. It was completed in 1949.
And it's a result of the 37 flood?
1937 flood is what propagated many flood walls up and down the Ohio River Valley.
Okay, now tell us a little bit about what it took to construct it. 10 years to construct. What is all involved? People see the concrete and they can see a levee, but there's a lot more to it than that.
A lot more. Like the wall that you see next to us right now, it's bigger underground than it is above ground. There's huge foundations that stop the wall from being overturned by water. Like I said, 10 years to build. Back then they didn't have modern heavy equipment like we do now. They had steam shovels, clamshells, cable-driven equipment, but not hydraulics and those kind of things. So a lot more labor intensive, more manpower, not in equipment.
And there's also gates and pump stations. Tell us a little bit about those type things that we have in this wall.
A lot of things we just take for granted. There's 12 pump stations that are around town that are strategically located. The gates, there's over 77 gates. There's 55 of these openings that we have. And I've been told by the Louisville District Corps of Engineers that for, I guess, a wall of our length, we have more openings than any other wall in their district.
Now, what does it take to maintain this wall?
Well, annually, we maintain 5 employees. We have a floodwall superintendent, Kenny Brannon. He's back here working with the fire department crews. And we have 4 full-time operators. And they do everything from mowing grass to fabricating steel, for replacing parts, to keeping parts lubricated, electrical components working. And so there's a lot more to flood wall maintenance than just what meets the eye. It's just not a freestanding structure. It is actually a living, breathing structure.
And these pump houses that the flood wall has, how old are the pumps in there?
The pumps are as old as the wall. They were the last items to go in. They were put in about 1947, 1948.
So the flood wall crew, they have to really work hard to maintain everything, to keep it going.
Well, one thing I'd invite us to do is maybe go look at one of our pump stations and see the level of maintenance that we maintain on it. Moisture is key. Electrical components are sensitive to moisture. We try to keep the humidity down in the building. And if you can keep the humidity down, you can maintain the life of an electric motor a whole lot longer.
Well, tell us a little bit about what it takes when we do have a flood. The last time these gates were installed was 2005, and so we really have to check every single day the gauge on the Ohio River.
Typically, we don't have to check every day, but once we become in the flood season where we start getting above 22 feet, we check it every day just to keep us, in a routine. Okay. But the river can rise and fall 6 feet overnight. It depends on what happens in the Tennessee River Valley and in the Ohio River Valley. Okay, whatever the dams are releasing, Kentucky and Barkley dams, will dictate what our water elevations are here in Paducah. Okay, in a situation where we might be in a flood season, maybe between November and March of a given year, we get 5-day forecasts from the National Weather Service, which tells us what our river elevation is going to be here in Paducah, as in Cairo or Golconda or any of those cities. And it's that forecast that we base our activity on. For example, the gates are the last things to go in because that's when the water's highest. However, There's many underground gates that have to be closed to prevent the water from entering into the city through our storm sewer system. And once we close those gates, then we have to pump any rainwater out of Paducah. So the river doesn't necessarily have to be up to this stage for this to go into activity. Our first operation goes in at 27.5 feet. Pump plant number 2 goes on it. When you see the river, like on the nightly news, if it's going to be at 27.5 feet, that's when our first pump plant's going in. And then we just work upstream. As the river rises, then we will engage more and more pump stations.
And so this gate behind me, when would it go in? It has to be pretty high.
It's the first day. If we have a river elevation predicted greater than 48 feet, we'll put them in.
Okay, well, Rick, we've got a lot more to talk about. I think we'll come back to you in just a few minutes to find out more about the future and what's going on with the flood wall. But let's talk to Kenny Brannon, our flood wall superintendent, to explain all the noise that's going on behind us. With a flood wall that's 12 miles long, you don't need to wait until you have a flood before you practice putting in the gates. And so that's what the crews have been doing over this week. They've been practicing putting in a floodgate and then taking it out, because with employee turnover, not everybody has had the opportunity to put in a floodgate. So we're going to talk to our flood wall superintendent, Kenny Brannon, about exactly what the crews have been doing over the last few days. Hi, Kenny.
Hi, Pam.
Hi. Now tell us about the crews. We have the fire department out here today. Who all gets the opportunity to practice?
Well, what we're doing today, we're taking different crews of different parts of the fire department, and each day they will have their turn at putting up this gate that they normally put up during the flood season. During a flood, and taking it back down. And like I say, the next day, the next crew from one of the other departments of the fire department will come in and do the same thing.
And we've also had the public works department out here too.
We've also had public works, refuse department, street department. Our flood wall guys have worked with those and tried to get them familiarized with everything that's being done, or to be done when we put these gates up.
So when we have a flood, it is the whole city pretty much coming together to put in these gates.
Yes, we have part of the city. We even have some of the county that comes in and does some of this stuff too.
Oh, wow.
So different departments of the city comes in, and they've got each one of the gates that they put up, that particular gate, and we usually keep those departments trained, try to keep them trained to where they know what to do whenever a flood occurs.
Now, I've been amazed at how fast they've been putting this gate up, and then they've already taken it down just in the last few minutes. How fast can they do one gate and put every single bolt that needs to go in there?
Actually, some of these gates take a little bit longer than other ones. This particular gate here usually goes up in 8 hours for 8 guys, to give you an idea. And some of the other gates, we have some that goes up in like 6 guys in 4 hours. So it just depends on what size gate we have in that particular area that they're putting up. So it just depends. We can usually get all of them up in one day if we need to. But that's provided with every department's doing their part.
Right. So how often do you guys come out and try to train? Every year, 2 years, or?
Well, it's probably been a little longer this time than it has been. We'd like to get to where we can do it every couple, 3 years, because that way you have a turnover of employees, and everybody learns what to do, and you can keep the new employees trained to be familiar with all of it.
Is it hard to train somebody how to do this? I mean,
Not
is
really.
it like a tinker toy putting it together?
Kinda. It's kind of like putting a puzzle together, so everybody knows what to do. All the pieces have got to go in the right places. And like I say, the flood wall guys have been here quite a while, so they know pretty well what goes where, and they're good about helping these guys get trained for this kind of thing.
I know when I first moved to Paducah and I saw the flood wall and I saw the doors, I had no idea that's where everything is stored.
We have, at each one of these openings, we have a vault that keeps all the material in, all the trusses, the panels that holds the water back. Everything is in those vaults.
Are those the original trusses and original equipment from when the flood wall was built?
That is the original stuff. Yes, it is.
Is it hard to maintain it because it's not like you can call and order a brand new piece, or are they just really well made?
Well, I'd say they're well made, and they are, like I say, some of these are 60 years old and they're still good as they was the day we got them, just about. You have to do a little maintenance on them here and there, you know, but pretty well they're just like they was when they was pretty new.
Well, walk us through the steps. I know we've been watching the guys putting the covers back down on it. What are the steps when you first come out here to install a flood wall? Kind of walk us through what would you have to do?
Well, first of all, when you come out, whether you see where these plates are that's out here on this area here, you pull your plates up You got your brackets and all the holes, the trusses in place. You put your trusses in, put all your purlings across these trusses. Once you get all the purlings across there, all the panels go in. In behind these panels, you got some seals that seals on the bottom and on the ends and where they join together. This is a newer type opening right here. It's got the rubber seals in between it. The other side has got some tie downs where you turnbuckle them down and tie them down with pressure points to hold them down where they won't leak.
It's hard to believe that it's waterproof when it gets through, or does it have a little bit of leak? Or
you sometimes maybe get a little bit of a seep, but most of the time it's pretty watertight.
Okay. Well, I think your phone is ringing. You're being called to action. I think coming up, we're going to let Kenny answer the phone, and we're going to go back and talk to Rick Murphy about some of the things going on right now to make sure that the flood wall has a longer life. I've now headed indoors inside one of the pump houses that we have here along the flood wall. I'm joined back with Rick Murphy, our city engineer and public works director. It's very hot inside this house today, but we're inside one of the pump stations. We are at North 8th Street?
We're on North 6th Street.
North 6th Street.
Pump plant number 2.
This is number 2. Is this the biggest one?
This is the biggest pump plant we have in the city's system.
Okay, we've got a schematic here behind us, and before we show what's going on in the pump station here, what are we looking at on the schematic? Because it looks like there's a lot of stuff, but we can't see all this.
Well, Pam, this is basically the ground level of what you would see from the exterior if you were driving by the pump plant. What a lot of people, or the people in Paducah, don't realize is the infrastructure that's underground. Yeah. These are the 5 pumps that we have in this station, and this is actually the portion that actually lifts the water, and then it discharges it through the flood wall and dumps it into the Ohio River. It's this area here that fills up. It enters through the storm sewer system through here after we close the gates. We close the gates to the Ohio River at 27.5 feet, as we mentioned earlier. And when that goes on, we're actually pumping the effluent from the treatment plant and all the rainwater. It enters the station, it's lifted out, and then it's discharged to the Ohio River.
It's not held. This is not like any kind of holding chamber.
It's not held. It's just a collection chamber to collect it and discharge it through the flood wall.
Well, let's talk about the pumps. There's 5 different pumps, and they're huge. And the first one we have is the small one, right?
Actually, the one we're standing next to is this pump right here. It's a 50 horsepower pump.
There's 6 pumps.
Then this is a 500 horsepower pump, another 500 horsepower, a 200 horsepower, and 2 800 horsepower. Now, this was drawn in 1937. Or excuse me, this drawing is 1952. Okay. What the station looked like in 1952. In 1996, we had a pump upgrade where we actually replaced the motor control system. That's where the electric energy is provided to all these pumps. We replaced the motor control, and we added a variable frequency drive pump to discharge the treatment plant. And it's a 100 horsepower pump that's over here in the corner, and we'll get to that in a second.
But these motors, are they all original?
All these motors are original equipment.
Wow, that's incredible.
This one motor right here was rebuilt about 5 years ago. About 5 years ago. Okay. We sent it down to Nashville to a company to rebuild that motor. Was $16,500. An equivalent 500 horsepower pump, just the motor. Now I'm not talking about the pump, just the motor alone could be $50,000.
Well, let's turn around here and take a look at some of these for scale, because when you see how big they are, it's incredible. Now, what size is this one?
That's a 500 horsepower Westinghouse motor. Okay. This is the one we actually had to rebuild. It was smoking. We turned it off, and then we made a few phone calls and said it's probably the windings need to be rewound on it. So we contacted the company that specializes in winding motors. They came down, and we have a big overhead. There's a big overhead hoist that's in every station. Okay. Now this hoist has a chain drive on it, and you can actually come over to this pump motor and lift it up and carry it to the door. Okay, and that's how all of it was brought in as well.
Well, we've got some other pumps here that are even bigger.
Right.
That one's, what, 800 horsepower?
We got an 800 horsepower pump. These pumps will 99,000 gallons a minute.
99,000 gallons a minute.
And what I like to do, we've had elementary school age kids over here, and you say 99,000 gallons a minute, but they don't have any real scale for that. But they all get their cereal in the morning, okay, before they go to school, and they see that gallon jug, and then the way I explain it to them is that if you can only imagine 99,000 gallons of jug of milk, that's what this does in 1 minute, in 60 seconds.
It's hard to even empty 1 gallon out of your milk jug in about a minute. Sometimes it'll slow down on you.
But the total capacity of this pump plant is over 300,000 gallons a minute.
And this one is what most of downtown.
Most of all the downtown storm sewer area collects into this station. All of the Noble Park area, or well, I would say that there's a big portion of this side of town, Lower Town, Fountain Avenue, all comes to this station.
So when the Ohio reaches, what was it, 27 and a half?
When Ohio River reaches 27 and a half feet, we actually shut ourselves off to the river, because the river is actually backing up into our system through the piping system. We shut that off to the river, and then what we start doing is, when the flood wall was built, we weren't that environmentally sensitive. We were discharging raw sewage into the Ohio River. Well, this was completed in 1949, okay? In 1957, 8 years later, the treatment plant came on, whereas we actually collected all of the domestic waste coming from each resident, treating the water, and then turning it back to the river. Well, that came 8 years after this was built, and then we started operating this at 27 and a half feet, okay? Normally, we always talk about local gauge, which is based on a 50-foot vertical scale. But this one goes in at 27 and a half feet, and then others come online as the river goes up.
Now, at 27 and a half feet, all these pumps wouldn't turn on. No.
At 27 and a half feet, what we try to do is just keep up with the need. For example, if there's a certain amount of water coming in here, there's inside the control room, there's a PLC, a programmable logic computer, okay, that is interfaced with a float or a device that's measuring how fast the water is rising in the wet well. And what the operator tries to do is just try to maintain an elevation in the wet well. That's the big space that's below our feet right now. When he sees that he's holding an elevation, then he'll stop engaging pumps. But if he's losing ground, if the water continues to rise in the wet well, he'll keep putting more pumps on until he can catch up with it. And then once he pumps it down, then he'll disengage pumps.
And if he can't keep up with it, does another pump station go on?
No. This is our maximum capacity. If, for example, we have one of those 97 events.
97 flood
event. Yeah. Okay. Or, we had several rains in 97 that came on like that. There's only so much capacity we have in the system. You could have some flash flooding in some areas because the pumps, the pipes, they're full, they can't take any more, and there's only so much mechanical ability we have. And once we reach that capacity, then we start filling up, in the reservoir of the community.
What else do you want to show us in here? Do you want to show us where the operators?
Well, the operator will man, when this station comes on, we will man it 24/7 as long as we have rain in the forecast. It's just a person that we have hired temporarily, and we'll man it. We'll have 3 separate shifts, and what they're doing is they're watching this board here, and there's like I said, the PLC I mentioned earlier. As the wet well rises, it will signify or indicate to the operator what he needs to do, whether he needs to put another pump on or take a pump off.
But he's just sitting here watching the gauges, watching the pumps, and watching a little bit of TV, because I guess it can get a little monotonous.
Well, that, and there's other things he has to do periodically, or he or she. We do have females also that help us with our pump operations. They have to go around every 30 minutes, and they'll check these reservoirs. These reservoirs, there's several valves here. Each valve goes to a bearing that's below the surface. Okay, these are just gravity fed, and they'll go around and they'll check the oil in the reservoir. They got just a little tin can. They go around and they pour this oil in, and then this keeps constant lubrication on the bearings as they're running. So about every 30 minutes, they'll circle through the pump plant that they have running, and they'll check the reservoir as far as its amount of oil that's in it.
Okay. Well, I think the last thing that we want to talk about, we may go outside and take a look at a couple of the pipes and talk about how we need to talk about the future of making sure that the flood wall continues.
Well,
you're dying to say something else.
One thing I'd like to add, Pam, is that we've been replacing a lot of the motor control systems throughout all of the stations. Right now, the Corps of Engineers is completing a feasibility study and certification study. But prior to this process taking place, that motor control system that's right there, that PLC, and that 100 horsepower pump that's over there in the corner, just those three items alone is $250,000. Okay, now if you want to start talking about rewinding, rebuilding pump motors, replacing pumps, you know, the motor is one thing, what it's actually turning is the pump element itself. It gets really expensive fast. So part of this feasibility study is to see, okay, if we're going to restore the flood wall to its original protection or level of protection, then all of the elements have to be functioning, you know, the way they were on day one. So they have reached the end of their design life. Now it's time to restore them. Okay, we have to complete that feasibility study in order that we would qualify for money from the government at a 35% cost share, and we're actively doing that.
We need to be reimbursed for all the work that we're putting in.
Right, because those are not reimbursable items. Even though from '96 to present, we've put $1 million of Paducah taxpayer dollars in rebuilding this infrastructure and trying to maintain it. Now we're at the end of the design life of this system that you can't do it with $1 million. It might take $5 or $7 million to do that work. Okay. So we would like to share as much of that with the federal government as we could.
Oh, definitely. We want to share. We want to share all that money. Okay, well, let's head outside. I think it might be cooler outside, and we're going to talk about a process called slip lining. Stay with us. Well, I have gone all the way down a hill and gotten down to where the pipes are that go through the flood wall. I'm filthy and Rick Murphy's holding my shoes. I guess you should have carried me down here. But the only way I could get down the hill was to take the shoes off. Okay, Rick. We are looking at a series of pipes that go through the flood wall, and these pipes have been renovated so that they have more of a life to them.
Correct.
Explain what was wrong with the pipe and what you've done to make sure that they're going to last a while longer.
Okay. The pipes, Pam, that were originally constructed 60 years ago were corrugated metal pipe. Nothing has an infinite life span. They've deteriorated over time. When the Corps came through and did their inspections, they kept talking to us about the corrugated metal pipes and that we needed to make repairs to them. Well, this is the time that we were working through with our Congress or our federal representatives to help get us some money to help us with this project. We're actually in the process of completing that project. It's a $1.8 million project to slip line these these pipes. Now, what takes place is you can see in this area here, this is the original corrugated metal pipe. It's a little bit larger, and this is the new liner pipe. It's a whole boss pipe that's been slid inside of it, and the purpose for slip lining as opposed to digging up is obviously the saving in the expense of the construction. If we had to dig these pipe up, all this concrete would have to be removed, the entire levee would have to be removed. So this is what we call a trenchless technology, whereas you slide a liner pipe in, and then you fill the void of the hose pipe to the liner pipe with the cementitious material, grout, concrete. And what we try to do is we try to fill the entire void, and then also expect that grout to migrate outside the pipe and fill any voids that might be in the levee as a result of erosion of material coming inside the pipe and then being carried off by the flow of water.
Now, since you put a smaller pipe inside a larger pipe, have you really reduced your flow that much?
I'm glad you asked that question, Pam, because if you're in the engineering environment or hydraulics environment, there's what we call coefficients of frictions. And Manning's roughness coefficient. That's how smooth is the pipe. The rougher the pipe, the less it'll carry. The smoother the pipe, the more it'll carry. However, the difference in a smaller pipe and a larger pipe is the exit velocities will be higher. So we have to watch out for scour. But this is a real smooth inside pipe as opposed to a corrugated metal pipe that's shaped like a waffle. Okay. So waffles are real rough. This is really, really slick. So the capacity is not diminished, but the pipe is made smaller with less friction, but exit velocities are higher. We got to watch scour.
And so this process is called slip lining.
Slip lining.
How many pipes do you estimate that we're doing?
We're doing 37 pipes.
37.
37 pipes. They range in size from 24 inch up to 113 inch.
Wow. Well, I think we're about to run out of time pretty soon. What else do you want to share about our beautiful flood wall? There's so much underground that people don't realize.
Right now, our flood, every project in Paducah seems like it's touching the flood wall. And what I mean by that is whether it's a downtown renovation, whether it's new industry coming to town, like the river industry, building their new operation centers. And it's what I'm calling second generation development, because first generation, those buildings have pretty much reached the end of their design life. We're coming in and investors are coming in and reinvesting in the river. So almost every project I have in my office right now has something to do with the flood wall. At the same time, we're doing certification, feasibility studies, and renovations to the flood wall, as well as building greenway trails on it. Our old philosophy was no trespassing. Don't, let's stay away. There's a lot of dangerous elements out here. I mean, when there's water flow coming through here, we have to be sensitive to that. But now we're looking at putting a trail on it, a greenway trail on it. So now we have to prepare it for a family that might be taking a hike or something on the trail. So we're going to other steps to make it, I guess, more aesthetically pleasing. But we've gone from no trespassing to come play.
And so we have to have proper signage and protection and things like that. But it is such a part of Paducah. It saves Paducah from flooding, and it has a beauty to it, especially from an engineering point of view. This is a gorgeous thing.
Well, it's good for, like I said, it's a 60-year-old project plus. It's in need of renovation, and I'm hoping that we will get this back in a point of repair, that it'll be nothing more than just general maintenance and not concerned maintenance where it's big dollar or big ticket items. Like when we was in the pump plant, $250,000. You can, a small break here, like if one of these pipes were to collapse and we was to have to replace this right here, we would be looking at $500,000 at this one location only. And we're getting 37 pipes slip line for $1.7 million. We're getting a huge return on investment with that. And
it's because you're trying to prevent problems too.
True. It's preventive maintenance. It's preventive restoration. I've had this discussion with the Corps of Engineers and also with headquarters in Washington, D.C. about what is maintenance and what is restoration. This is restoration. But like I said, the return on investment is very high, because you can imagine digging this out as opposed to sliding pipes in and grouting them in and still not losing any kind of capacity.
Okay, well Rick, I think we're going to try to figure out how to get out of this mess that you've got me into holding my shoes. I don't know, are you good at piggyback rides?
I can deal with that.
Well, you've been watching Your City at Work. You've been learning all about the flood wall. I've had a lot of fun. I've sweated probably 5 pounds, and I have dirty feet. Well, I wouldn't say it's one of my dirtiest jobs, but definitely I've had a great time. So I'm your host, Public Information Officer Pam Spencer, and you've been watching Your City at Work.
Hold on, give me a shoe. Hold on, quit it.
I will want my shoe back.
I'm gonna get him.
That was his nest, I think.
I know it was.
With my shoe.
I think I got it.
Ah, you got him.
Here.